In this next video, or in this next issue that we are going to tackle, we will continue to prepare our walking skeleton. And in particular here, what we are going to do is to use Postgres, the database engine, as our main data source. And the reason for that is that when we switch to Heroku and deploy it there as a test environment, we also need it anyways. And from my experience, it's just easier to use the very same database in probably the same version on your local development and also in the CI pipeline as if you would do it in the deployed environment. So this is the first part where we just configure it locally and then also in the pipeline. And the second part is then actually deploying our test environment to Heroku. With the previous video, we have everything already prepared from the Terraform side. So let's now look into this on how to make it real running in the Heroku. Okay, so for that we will switch back to our application here. And the first thing is that we need to set up our local environment to run the Postgres. And for that, it is actually, so I will use Docker here in this respect, just because I don't have it installed locally, the Postgres binary itself. And I would suggest you doing the same. I will prepare here a Docker compose file, which is just starting up the Postgres instance. And yeah, we can probably go into the details here and look how to configure it. So the first thing is that you specify a version here in this about the Docker compose schema itself, and then we can define a couple of services. In this case, I will configure here the Postgres image and use that as so we can also probably just call it Postgres. And we just define it a particular image which will be downloaded from Docker Hub. In this case, it will be the 13.5 because this is the same version of Postgres that that Heroku is also running. And then the next thing is that we want to configure the port mapping. So this means on my local machine, when I connect to it from my Mac using the regular IntelliJ or whatever, then it should be available on localhost 5432. This is just a regular port from Postgres. And in the container, it also should map into this port because the Postgres Docker image just uses by default this one. And then we can set a couple of environment variables, which will be, just configuring the default database and the master user and the password. And I just configured that here so that when we run that, we can basically mirror the same settings in our IntelliJ. And yeah, with that, then be ready to connect to the database. And the last part is that when you develop locally, you normally do not want even your test data to be disappearing every time you restart your container, which is the default behavior from Docker. So in this case, what we can do is we can configure a volume, and this volume means that so in the container, Postgres will look into this directory var lib PostgreSQL data, and there it will just fetch the underlying data file system for the database. And what I do here is I just configure it to be locally in my host machine in this directory .jmix and then not HSQLDB, but instead Postgres. So with that, it should be actually possible to, even when the Docker compose is not starting, or like we restart the Docker compose, then it still should use the same data source, and in particular the same data. So with that, we should be able to say docker compose up, and now as you see here, it starts, you see the logs of the Postgres container, and it starts now the application, and it says now ready to accept these connections. So for us, this means, and you also see here now we have the Postgres directory. So this means we can go here to Jmix and switch the data source locally, and just double click on this menu entry, which is currently has the icon of the HSQLDB, and I will just switch it here to Postgres. And then, I prepared that already before, but you can just, we have to mirror this Postgres database and the DB user and the password. Then if we look at the supported DB types, now it's only set to Postgres, which is fine in our case. And the database identifier length mode is also set to Postgres. So this means that IntelliJ, or in particular this Jmix plugin, will warn us if there's, lengths of entries that like table names or something that are more than 63 characters, because this is just not possible apparently in Postgres. Okay, so this should just be fine. So then we can click OK, and what now happens, let me just switch back to to the project view. If we go to the application properties file, then you can see this main data source URL section has been changed. And if I now run this application, then what happens is, as you see here, now my main application database is PostgreSQL and its localhost rent your stuff. The port we didn't configure because it's just the the regular port from Postgres, but yeah, anyways. So what now happens is that Jmix plugin found there's no data in the database yet, or not even a schema. So therefore, it would like to once again create the Liquibase changelog and basically execute them that come from our application, but also from the Jmix itself. So here you see this is like a file from the UI data section, or here from the security data section, and so on. So we can just go ahead and execute that. And now it should start up the application. And one thing that you can also use in IntelliJ is use this database tab here and create a new data connection. And in this case, I will just connect to my local Postgres database. So let me just do that here. We have the host is localhost DB, and the port is 5432, and username and password should be fine, and the database is rent your stuff. So here IntelliJ tells me to download these driver files, which I have to do before I can actually connect to the Postgres database. And now if we say test connection, it should just be fine, and yes it is. Okay, so this means I can just save these settings, and now I can basically see all the stuff that is in my database. And as you see, the database changelog has now been executed, and therefore we already see our tables here. So when we now go to our running application, we can basically, for example, create a user for myself. And just start this one. So, and if we go back to IntelliJ now and take a look at the users table, then we should be able to see my user here. All right, so this is already a very good first step. Yeah, so perhaps the next thing is that we just to show it to you once again. So if we now what I wanted to do is to basically restart my Java application, but also my database, and it should still be the same data. In order for that, first let me assign a role here, which is just the full access role to this user, and let's see if we can right now log in. Yes, so this just works. So coming back then to the IntelliJ and stopping my application. I can here, for example, make a Command C to stop the containers. Yeah, and now the Postgres is stopped. As you see here, if we now try to connect to it, it says, connection refused because there is no connection anymore because the database server is down. And now the next thing, just doing a Docker compose up once again. If you do not want to have it open all the time, this local terminal here, you can also say -d, which is just fires up the same container as the Docker compose, but it just runs that in the background. So you can still see that if you do a Docker ps, then you should be able to see your running Postgres application. And now if we connect once again to the database, it's now the connection. We have it once again here, and as you see, the data is still there. So this means if I now restart my application, it should actually, be possible to once again connect to via my new username. And exactly this is what happens. So with that, we have created our, or achieved our first goal here is to run Postgres locally via Docker. All right, and the second thing that we want to do is to configure our CI pipeline. So let me stop my application for now and just also stop the Docker environment because I don't need it right now anymore. And the next thing, so let me just for now create a branch, say so which issue is that? Number 4. Okay, and now we see, mainly for changes our Docker compose file, and then the build Gradle, which we can just take a look at what has actually changed here. It's mainly just the driver. So here we use the HSQLDB, and now we use the Postgres driver. This has already been changed by the Jmix plugin. We have the Docker compose file and the internal settings from the data store settings from Jmix Studio. So let's all put them into one commit, saying run Postgres locally and commit them accordingly. So the second thing, as we already said, we want to configure it to be running in the CI pipeline. So if we look at our application properties, we will find that now, it's hard-coded that we say we expect a Postgres server on localhost and the database is friend your stuff. If we go back and take a look on how this looks in the GitHub Actions, then so this was our last commit from the previous video, but here there is no Postgres instance yet, so this means the test will actually fail. In order to fix that, we can reconfigure our test environment. And so for that, we go to the workflow CI pipeline YAML file here. And here you see, we have a CI job, and that is actually setting up the JDK, and then it runs the tests. So what we have to do now is to basically spin up a Docker instance there as well as a Postgres. And actually GitHub supports that. I can just pull it in here. So what GitHub Action has is a thing which is called services. And these services are basically under the hood also Docker containers. And you can basically interact with them in the same way as we already did locally in our Docker Compose file. So you can say, I would like to have a service called Postgres. It should use the image Postgres. With this, actually, we can just to also match our exactly the same image here. Then we configure the database to be rent your stuff, DB, user, and password. And although this is already, fine to spin up this service, there's also another option which allows the CI system to wait until Postgres is actually correctly initialized. And with that, what we can do is now we just have to tell our application that we have a particular Postgres instance running under a particular host name and so on. And here, these settings, these main data source URL and so on, these are just Spring Boot standard application properties. And Spring Boot has this capability that you can either configure these values in this form in this file, or doing it as a command line parameter for your Java command. But what is also possible is to just say, I would like to have an environment variable. And this environment variable will be, all uppercase, and then the dots are replaced with underscores. And then Spring Boot, and therefore Jmix, will, just pick them up and treat them as the values that it should take. And these are will actually override the values that are here. So this means we can just reconfigure it. So for this one, we can have this step here, which is called run tests. And what we do here is to place these environment variables and just say, I would like to specify the data source URL and the username and the password. So with that, our test Java is now capable of understanding where to connect to the database. Except there's one gotcha that when I prepared this video, actually fall into. And this is not super obvious. So in GitHub Actions, there are two ways on how you can run your steps. So the first one is, as we have configured it here, to basically it will spin up like a VM. Here it says run on Ubuntu latest, and it will immediately run on this server. And then this is the the host instance, as we have here done it with our Mac. Yeah, so I started the Docker Postgres, and I connected to it from my local Mac host. And this is basically how it's configured right now. And there's also the second option, which is that we run all these steps in a particular container within this VM. And if you run it in a container, then this container where actually the Gradle test is performed has the possibility to directly connect to this different services here that we configured in the same Docker network. And therefore, the the database name will be the one that we configured here as the name of the service. If we don't do that, we would have to do it via localhost, but I will now go ahead and just configure it to run all these steps in a particular container. And this is possible when we say we would specify a container for all of the steps. And I just said, it should be Ubuntu latest, so this is a Docker image. And with that, it should actually be fine to connect to our Postgres database. So let's actually take a look. And we now just have our CI pipeline changed. So I will just add that here and so I just locally created a branch feature for Postgres DB before, but I have not set a corresponding remote branch. So instead, I will just create a pull request, and the GitHub CLI will just guide me through the process. So yes, it should be in this repository. Yeah, the title is just fine. We can just leave it for now. And I will just submit this, and then it will push all the stuff to this new remote branch. And since we configured initially our CI pipeline to also run on pull requests, it actually will start, and we can take a look if this actually happens. As you see here now, the CI pipeline is in progress, and it will just set up everything that it needs. So there's a lot of stuff that comes up, but the interesting part probably for us, not the git checkout. Let's take a look at this one here. So here you see starting Postgres service container, and there it actually downloaded our Postgres Docker image, and then it starts the Postgres with our corresponding settings, and then it just with these waiting commands, it just waits for the Postgres to be up and running. And so now our test run is actually happening, and what we see here once again is the environment variables that we have configured for this particular test run, as we have defined it in the YAML file. And let's just take a look at what happens. Okay, so the build seems to be fine. Test results are actually just running, and it's good. So with that, we have basically also achieved our second objective here, that we would like to configure our CI pipeline to run with Postgres. So with that, we can just I just changed the title here, and now we can commit our change, and it actually fixes our issue number 4. And now we can merge this one. And with that, we have finished up this story, and yeah, we are done. We are done with the video. See you next time.